Hi there, folks. This is the Practice Chapter 6 test, and as always, I am the mystifying and magical, yet always magnificent, Mr. Jansen. And if we take a look at the first one's asking us to solve by graphing. When we solve these by graphing, we're simply going to graph each of the lines on the coordinate system, and then just see where they intersect. So when I look at these, each of these is already in slope-intercept form. The first one has a y-intercept of -4 and a slope of 2, so I go up 2 over 1. Up 2 over 1, and I draw the best line that I can. And it's important to try to be accurate with these. The second line, we've got a y-intercept of 1 and a slope of -3, so I go down 3 over 1, down 3 over 1. Once again, I draw the best line that I can. That one wasn't very good. Let me try again.
That's better.
And when I look at this, I can see that they intersect right here. They intersect at the ordered pair 1, -2. And what that's telling me is that x equals 1 and y equals -2. It's solved for both variables simultaneously. And I'm just going to leave that as an ordered pair. It's a nice way to write my answer. In number 2, I'm going to graph these, but the problem is that these aren't in slope-intercept form. So I'm going to take this first one, and I'm going to put it in slope-intercept form so that I can graph it a little bit easier. I've got to add the x to each side, and that's going to leave me with a 2y equals x plus 4. And then I have to divide each side by the 2. And just be careful here when you divide each side by 2. Over here I have to divide each piece by 2, and that's like a 1x. So I do 1 divided by 2, which is 1/2 x, plus 4 divided by 2, which is 2. Now that one's in slope-intercept form. I have to do the same thing with the second equation. I'm going to put it in slope-intercept form. And in order to do that with this one, I have to add the 3/2 x to each side, which is going to leave me with a y equals 3/2 x. And now they're both in slope-intercept form, so now I'm going to graph each of these. The first one has a y-intercept of 2 and a slope of 1/2. That's up 1 over 2, up 1 over 2, or down 1 back 2. And again, I draw the most accurate line that I can. I do my best. It's important to be accurate with these. And then the second one, it's got a y-intercept of 0 and a slope of 3/2, which is up 3 over 2, up 3 over 2. And once again, I draw the best line that I can. And it looks like they intersect right here at the ordered pair 2, 3, which once again is telling me that my x equals 2 and my y equals 3. I've solved for both variables. And I'm just going to leave it as an ordered pair. For these next two, it asks us to solve by substitution. And really, this first one is a great example for substitution. With substitution, I have to solve for one of the variables in one of my equations. And in this one, the first equation is already solved for y. So y equals the 3 minus 2x. So now I'm going to go to my second equation, and I'm going to plug that value in for y. So I've got 3x plus 2y equals 1. But instead of y, I'm going to plug in what y is equal to, which is this guy right here. It's the 3 minus 2x. So I plug that in for y, and the effect that that has is it gives me one variable in this equation, just x's. So now I'm going to solve. I distribute the 2. Remember, always simplify and then solve. So I've got 3 plus 6 minus 4x equals 1. Now I can combine like terms, the 3x and the negative 4x. Since they're already on the same side, I just combine them. That gives me a negative x plus 6 equals 1. And now I subtract the 6 from each side. That gives me a negative x equals a negative 5. I have to divide each side by a negative 1 because there's like a negative 1x there. So in order to flip the sign here, that's going to give me a positive 5. So x equals 5, but I'm not done yet. I still have to find y, which means I need to go back to the original equation, the one that was solved for y, and plug this in. Let me scoot this 1 over to give myself a little more space. But I'm going to have y equals 3 minus 2x. But instead of x, I plug in what x is equal to, which was the 5. So now I've got y equals 3 minus 10. So I find out that y equals a negative 7. And then once again, I can write that as an ordered pair, 5, negative 7. It's just a nice way to write my answer. Okay? For the next one, neither of these is already solved for variables, so I have to solve for a variable. I'm going to take this first equation, and I'm going to solve it for x. So I'm going to add the 3y to each side. That's going to leave me with an x equals 3y plus 9. Now that I know what x is equal to, now that I know that x equals this whole thing right here, I'm going to go back to the other equation. I'm going to plug that in for x. So the other equation I had x plus 2y equals a negative 1. But instead of x, I'm going to plug in, let me write it this way. It's x plus 2y equals a negative 1. But I'm plugging this entire thing, the 3y plus 9, in for x. And really, I don't need the parentheses there, but it's just a nice way to show me plugging it in. Now I can combine like terms. So I combine the like terms. That gives me a 5y plus 9 equals a negative 1. I have to subtract the 9 from each side. That's an ugly looking 9 I made. So I find out that 5y equals a negative 10. Now I divide each side by the 5. And it gives me y equals a negative 2. But I'm not done yet. I still have to plug this back in and find x. So I go back over to this equation. X equals 3y plus 9. But instead of y, I plug in the negative 2. So that's a negative 6 plus 9. So x equals a 3. So the ordered pair is 3, negative 2. Solving my substitution. Okay? For the next one, we're still solving my substitution. Once again, this one is set up really nicely for us. It's telling us that y equals the negative 3x plus 1. So I'm going to plug that in for y in my second equation. So what I have is y equals the x minus 7. But instead of y, I'm going to plug in what y equals, which was the negative 3x plus 1. And of course, once again, I don't need these parentheses. It's just me showing you why we're doing this, how we're plugging it in. Now I've got to get the x variables on the same side, so I'm going to add the 3x to each side. I always take care of the variables, get them together first. So I have 1 equals 4x minus 7. Now I can add the 7 to each side. So that gives me 8 equals the 4x. I have to divide each side by the 4. And I find out that x equals a 2. But I'm not done yet. I still have to plug that back in right here. So I find out that y equals a negative 3 times x plus 1, where x is a 2. So I've got y equals a negative 6 plus 1, which is a negative 5. And once again, it's the ordered pair 2, negative 5. It's just a nice way to write my answer. The last one that we have to solve by substitution. This one is easy enough to solve by substitution. I have to isolate one of the variables. For this one, I would solve maybe the second equation for x. So I'm going to solve the second equation for x. I'm going to add the 2y to each side. That's going to give me a negative x equals 2y minus 3. And now I'm going to divide each side by the negative 1. So I get x equals a negative 2y plus 3. It just changes the sign of everything. Now that I have what x is equal to, I'm going to plug that in for x back up here in the first equation. So in other words, I have 2x plus 4y equals 6. But instead of an x, I'm going to plug in what x is equal to, which is a negative 2y plus 3. And now I just have to simplify this. I'm going to distribute. So I distribute the 2. That gives me a negative 4y plus 6 plus 4y equals 6. And now I combine like terms, the negative 4y and the positive 4y combined to give me a 0, which just leaves me with a 6 over here. So I end up with 6 equals 6. Remember, this is one of our special cases. When I get a true statement like this, I say it's infinite solutions. Remember, this is our symbol for infinity. It's infinite solutions. Which means I have the same line written twice. They just look a little bit different, okay? If we got a true statement, it's infinite solutions. A false statement means it's no solution. For these next couple, we're going to solve by elimination. Remember, elimination, we need additive inverses in front of one of our variables. For this one, I already have additive inverses in front of the y's, so I'm just going to add these equations together. I add them up. The 2x plus the 3x is a 5x. The y plus negative y cancels out. The 5 plus a 20 equals a 25. And now I just have to solve what's left. I divide each side by the 5, and I find out that x equals 5. But I'm not done. I still have to plug this into one of my equations. Doesn't matter which one. Whichever one looks easier. I'm going to plug it into the first one. So I've got 2x plus y equals 5. But instead of an x, I'm going to plug in what x is equal to, which is the 5. So I've got 10 plus y equals 5. I subtract the 10 from each side, and I find out that y equals a -5. So once again, it's the ordered pair 5, -5, and that's it. Forgot to put the parentheses around my ordered pair. There we go. And I erased part of my 5. Okay, so it's x equals 5, y equals -5. For the next one, I don't have additive inverses, so I have to get additive inverses, and I can either do that in front of the x, or I can do it in front of the y. I'm going to go ahead and do it in front of the x, which means I'm looking at the 3 and the 5. And it's almost like getting common denominators. I need to get a 15 in front of each of those. So I'm going to multiply the second equation by 3. Whatever I do to one side, I have to do to the other side. And I'm going to multiply the first equation by 5. But instead of by 5, I'm going to multiply it by -5 so that I can get additive inverses. So one's a positive and one's a negative. Okay? And what happens here is the first equation, when I multiply everything by -5, it's going to give me a -30x minus 15y equals a -30. The second equation, when I multiply everything by 3, is going to give me a 24x plus 15y equals a positive 36. And now I have additive inverses in front of the y, so I can add these equations together. So I'm going to add them up. When I do the -30x plus the 24x, it gives me a -6x. The -30 plus 36 gives me a 6. And of course, the y's canceled, which was the point. That's why I multiplied those by the things that I did. I divide each side by the -6, and I find out that x equals a -1. But I'm not done. I have to plug this into one of my equations. I'm just going to use the first equation. It was a 6x plus 3y equals 6. But instead of an x, I'm going to plug in the -1. So I've got -6 plus 3y equals 6. I have to add the 6 to each side. So I find out that 3y equals 12. Divide each side by 3 to give me a y equals 4. And that's it. Ordered pair is -1, 4. For number 9, I can either get additive inverses in front of the x or in front of the y. I'm going to go ahead and get these in front of the y. I'm going to multiply the second equation by a -3. Because that has two effects. It changes the number in front of the y to the 3 that I want, but it makes it a positive 3. So again, the first equation was this guy. It remains unchanged. The second equation, when I multiply it by the 3, or by the -3 rather, gives me a -12x plus 3y equals a -27. Now I can add these up. I have additive inverses in front of the y's. The x's added up give me a -11x. The y's cancel. Over here, that gives me a -11. And now I just have to divide each side by a -11. So I divide each side, and that tells me that x equals a positive 1. But I'm still not done. I have to plug this in. I'm going to plug it into the first equation, so I have x. So let me write it like this. X minus 3y equals 16. But instead of x, I plug in the 1. So now I have to subtract the 1 from each side. I get a -3y equals 15. I divide each side by a -3 and find out that y equals a -5. Okay? So once again, ordered pairs 1, -5. For number 10, this is set up pretty nicely for me. I just have to multiply the first equation by something. I'm going to get additive inverses in front of the y's, so I'm just going to multiply the first equation by a 2. See, it already had the signs the way I wanted them. One was a positive, one was a negative. The second equation stays the way it is. The first equation, when I multiply it by the -2, becomes a -2y plus 4x equals a -8. And now that I have additive inverse in front of the y, I'm going to add these together. 2y plus a -2y is 0. The 4x and the -4x add together give me a 0. So this entire side becomes 0 because all the variables got eliminated. And now over here, the 6 and the -8 add up to a -2. And this is a false statement. 0 does not equal -2. So this is where I say no solution. So be aware of those special cases. Okay?